Hey everyone, welcome back. This is Ebi here, and today we are diving into instance creation in the easiest way possible. By the end of this video, you'll have a solid understanding of how an instance is created. We'll walk through a simple Java program and explore it from a memory perspective. So, without further ado, let's jump right in. Before creating an instance, let's take a moment to discuss one of the key components of a computer system, RAM. Inside RAM, there is a dedicated space known as the JRE. It stands for Java Runtime Environment, where all Java programs run. Furthermore, JRE can be divided into four important segments. We have the code segment, the static segment, the stack segment, as well as the heap segment. These four are very important if you want to understand how a Java program actually works. The code segment is a place where all your Java programs get stored. We are not going to discuss about static segment in this video because it is a separate topic on its own. So I'll be making a separate video on it in the near future. But right now I want you to focus on the two segments here, which is the stack segment and the heap segment. All the references that we create are stored in the stack segment, and all the memory blocks get stored in the heap segment. Now, how does this actually work? Let us see with a simple example, okay? Here, as you can see, we have a simple Java program where we have a class called demo, and inside the class, we have a main method. Inside the main method, we have two lines. The first line is where we create the instance, and the second line is where we print the value of it. So what do you think will happen if we try and execute this code in our editor? So what would be the output? If a Java program needs to be executed, it needs to get the control of execution from the operating system. So that is what is happening here. The operating system has the control of execution, and now it gives the control of execution to the Java program. Now the control of execution comes and checks in the class, is there a main method? And obviously here we have the main method. So what happens? The control of execution comes inside the main method. The moment it enters the main method, something happens in the stack. A stack frame of main gets created. Now the control of execution comes to the first line inside the main method where we create the instance. If you observe carefully, you can see that we use a keyword called new. So why do we do it? Well, when we use the keyword new, a special person gets called, and that is nothing but the JVM. The main role of JVM is to allocate memory. So when we say new demo, now what happens is JVM allocates a brand new memory block in the heap segment, and obviously that memory block has a certain address. Let's assume it is 1000. Now we say D1. What is D1? D1 is a reference which belongs to the type demo. If it was an integer, I would have said int D1. If it was float, I would have said float D1. But here it belongs to the type demo that we just created. So we say demo D1. And then when we mention the is equal to sign, whatever is present in the right hand side is assigned to the left. What is present in the right hand side is the address of the memory, and that is what gets assigned to D1, which means D1 now points to the memory block which is at the address 1000. Now the control of execution comes to the next line, and here we have the print statement. So what are we printing? We are printing whatever is present in D1. What is present in D1? D1 stores the address of the memory block. So which means we are printing the address of the memory block. Now what happens? Control of execution goes to the next line, and as you can see, there is nothing there. So the control of execution exits the main method. I want you to remember something. When the control of execution enters the main method, which means your Java program has started its execution. The same way, when the control of execution leaves the main method, it means your Java program has terminated successfully. Here, as you can see, the control of execution has come outside the main method, which means your Java program has completed its execution. Now, what happens in the memory? Let's look at it. So, did you notice something? Look at the stack. The stack frame which was present got removed. And because the stack frame got removed, whatever was present inside it also got removed, including the reference variables. Well, the stack got cleared, but what about the heap segment? There is still some memory allocated. Now there is a small concept to understand here. When there is such a memory block in the heap which does not have any reference from the stack, such memory block is treated as garbage. And these garbages are usually collected by the garbage collector. This is a wonderful functionality provided in Java where the garbage collector keeps checking the heap, and if it finds any memory block which does not have a reference, it immediately deallocates the memory for such memory block. After the Java program has completed its execution successfully, the control of execution goes back to where it came from, and where it came from is the operating system. Now let's go to the code editor, run this program, and see the output that we get. The code editor that I am using is VS Code. You can use any code editor that you are comfortable with. Let us run the program. The program is executed without any errors, and okay, we get the desired output. So the output that we have received here is the address of the memory. So I hope by now you would have gotten a crystal clear clarity on how an instance is handled by Java. That's all for this video. See you in the next one. Bye bye.